actually the Rowler's law is following the ideal solution. Ideal solution. What are the ideal solution? How we say that is ideal solution like that? Let's see this video. The quantitative relation between the Rowler's law is a quantitative relation between partial vapor pressure and mole fraction of the component in the solution. We know that initially there is a studied the solution it containing the solute plus there is a solvent. Okay, so now the quantitative relation between the partial vapor pressure, how we write that is a, if you assume as a, okay, partial vapor pressure that is equal to and mole fraction of component in a solution. So there is a P naught of A and X of A. So this P naught of A as a pure solvent and X of A as a mole fraction of A. X of A is equal to, there is a mole fraction of A component. Okay, then P naught of A that is equal to pure solvent, and there is a P of A that is equal to partial pressure of A, partial pressure of A. Okay, A component. So the actual Rowler's law as a binary liquid system, if you assume the binary liquid system means the solution is containing only two components. One is a solute, another one is a solvent. For that, the quantitative relation between the partial vapor pressure and mole fraction, mole fraction component in a solution. That's for the Raoult's law. So the vapor pressure of each volatile compound in a solution is directly proportional to its mole fraction of the component in the solution at a particular temperature. Okay, so the mole fraction is directly proportional to of its partial vapor pressure. If you assume the partial pressure of a solution, if you assume as a solution is mixed with a non-volatile solute, there is a solution is prepared from non-volatile solute. Okay, so in generally we know that already the vapor pressure is depends on that volatile solute or volatile liquid. Okay, nothing but the vapor pressure, the surface of the liquid molecule is converted into the gaseous state at the top of the vessel. So that is creating for the vapor pressure we studied for the already last video. Okay, so now the consider the P of S is directly proportional of the X of the solvent. So the solution of partial pressure is only depends on that the solvent, because the solute are non-volatile, so non-volatile means that's a vapor pressure are inversely proportional of the non-volatile solute. So for that reason the solution is containing the vapor pressure, for that only depends on that the mole fraction of the solvent only. Okay, so here then we introduce a proportionality constant. Here there is a P of S is equal to, there is a P naught and X of the solvent. Here the P naught is a partial pressure of the pure solvent. P naught is equal to partial pressure of pure solvent. Okay, and the P of S that is equal to partial pressure of solution, partial pressure of solution. Okay, the next category, then here we know that the mole fraction of the solution is equal to 1. But in the case of the vapor pressure, if non-volatile solute, only depends on that the solvent. For that reason, the mole fraction of the solvent is also equal to 1. So the P naught or P of S is equal to, that is a P naught into 1. So the P of S equal to P naught. Okay, this relation one is more important. Okay, the next category, the second category, if you assume the if a solution is prepared by a mixing of two volatile liquid component A and B. Okay, so there is a solution is prepared from two volatile A and B. Okay, that is a both as a volatile, component. For that reason, we calculating the value, how the total pressure we will calculate. Actually, according to the Rowlett's law, the P of A is directly proportional to X of A. Okay, so the partial pressure of A is depends on that mole fraction of A. We introducing the constant, that is a P of A is equal to P naught of A, that is a X of A. And similarly, the partial pressure of B is directly proportional of the X of B, and partial pressure of B is equal to P naught of B, and that is a X of B. Okay, so there is a the two component both as a volatile. For that reason, we will make it like that, the formula. And the solution it containing the both A and B. The solution it have possessed the vapor pressure. For that reason, there is a total vapor pressure or total pressure is equal to total pressure of total is equal to P of A plus P of B. Okay, we know that both P of A and P of B value we can go to substitute here. So there is a P pressure of total is equal to P naught of A X of A plus P naught of B X of B. Okay, so now the X of A plus X of B, that is equal to 1, because there is a X of A plus X of B, X of B is equal to 4, that is a solution. So we know the mole fraction of already we written here, the mole fraction of solution is equal to what? The mole fraction of solution is equal to 1. For that reason, the always mole fraction of X of A is equal to 1 minus X of B. So always the mole fraction of X of A or mole fraction of X of B is less than 1. Any one we know, we will finding the 1 minus for that value we can get in. Okay, so the mole fraction of solute or the solvent always the less than 1. Okay, now go to substitute this value X of A value, this go to substitute here. So now we can substitute here what we can get, that is pressure of total is equal to, there's a P naught of A and 1 minus X of B plus there's a P naught of B and there is a X of B. Okay, so like that we can get in. So finally this formula is rearranged. Finally this formula we rearranged, we can get in that this value, that's a pressure of total. The pressure of total is equal to, there is a P naught of A and X of A plus P naught of B X of B. Okay. Okay. This formula for regarding the pressure of total and another one formula, that is a pressure of total is equal to, that is a P naught of B minus there is a uh, P naught of A, P naught of B minus P naught of A, and x of B plus P naught of A. Okay, so this one of the formula, and this formula is most important. This formula is the most important, and similarly there is a pressure of total is equal to P naught of A minus P naught of B, and here there is x of A plus P naught of B. Okay, these two formula is the most important actually for calculating for NEET and JEE problems. We will study by using these two formula, but it is a very lesser only. Okay, are very easy way, easy topic. Okay, then next third category one is there. There is a third category. So third category, nothing but if a solution is prepared by a mixing of two volatile liquid, this formula, and in the case of third category, composition of a vapor pressure can be determined with the help of a Dalton's law partial pressure. Okay, the Dalton law partial pressure is nothing but that is a pressure of A is equal to Y of A and pressure of total. If you needed to Y of A, that is a, if you needed to Y of A, that is equal to pressure of A, that mean partial pressure of A divided by total pressure. Okay, so now we know that P of A and the total pressure, both we can substitute here. That is Y of A is equal to, here there is a P naught of A and x of A divided by, there is a P naught of A and the x of A divided by, there is a P naught of A plus P naught of A plus there is a P naught of B minus P naught of A x of B. Okay, so this formula is most useful, and also I written here the similarly B, there is a partial pressure of B is equal to Y of B, that's a total pressure. So there is a Y of B is equal to P of B divided by total pressure. Okay, so there is a Y of B is equal to the P naught of B x of B whole divided by, there's a P naught of B plus, there's a P naught of A minus P naught of B x of A. Okay, so this also one of the formula, it's a most useful formula. Okay, now we go to the graph. Actually the graph is representing vapor pressure and mole fraction between that. Vapor pressure and mole fraction. Here there is a vapor pressure, here there is a mole fraction. Okay, so see the both as a the x of A and x of B is depend on that x of A is equal to 1 and x of B is equal to 0. Here x of B is equal to 1, x of A is equal to 0. So we know that the x of A as a maximum means for that related partial pressure as a maximum for here. Okay, from here there is a P of A as a maximum, but here x of B is a minimum, so for that the P of B also minimum here. Okay, and similarly in the case of left to right, x of A as a decreases, so that is a P of A also decreases, because the P of A as a directly proportional to x of A. x of a, and p of b is directly proportional to the x of b. For that reason, the x of a here is the maximum. For that, the p of a is also maximum. X of a is left to right is a decreases. For that reason, p of a also decreases. And similarly, here x of b is a minimum, and left to right x of b as a increases. So the x of b in with regarding the partial pressure also is a maximum. Okay, so these two is a total pressure, that is here there is a partial pressure of b. Okay, there is a total pressure. We what the pressure of total is equal to the p of a plus p of b. Okay, so now there is a p of b, what there is a p naught of b x of b, and the x of a, what that is, or here there is a p of a, what there is a p naught of a and x of a. Okay, okay. So in actual Rowlett's law, that's a linear relation, not in the deviation. It's a linear relation, and also see the limitation of that Rowlett's law. Limitation first, this limitation applicable only a very dilute solution. It is a only for a very dilute solution. Okay, because of that is a dilute solution, in the concentration term mole fraction is only there. For that reason, it's applicable only for very diluted solution. And the second case, applicable only is a solution containing non-volatile solute only. Okay, the second category, there is a solute or non-volatile. For that is only we can use it. And the third category is not applicable to a solute which dissociate or associate in a partial pressure of particular solution. It is a not dissociate nor associate. For that solution also not applicable. And Rowlett's law is applicable only for the ideal solution. Okay, that's only for ideal solution. But in practically in every solution cannot be say that is whether it's ideal. It's a ideal. It's just for imaginary. For that is a main drawback in the limitation of Rowlett's law. Okay. Thank you to all. If you like in this video, subscribe and share your friends. Thank you very much.